All right, so up till now we have talked about solving systems of equations by graphing. We talked about how to find that system, we talked about how to graph a line to find where the two lines cross, but now we're going to talk about some more algebraic methods, all right? So we're going to talk about using substitution to solve a system of equations, all right? So let's take a look. It takes 3 steps to get this done. 1, solve one of the equations for one of the variables. That'll be done for us today, okay? Step 1 will be done for us. Step 2, substitute the expression from step 1 into the other and solve for the other variable. Step 3, plug it back in. I'll show you what this means here in a second. Start with 2 equations. For right now, one of them will be in a variable equals form, all right? So what we need to do is we are going to do a substitution step. So let's pause this for a second. If I give you this and I ask you to substitute, what are you going to do? Yeah. I'm going to take this 3 and I'm going to put it in for y right there, and then 2x minus 5. Substitution, all right? It's like a basketball game. You substitute one player for another. The variable comes out. What the variable equals to goes in its place, all right? Substitution. So what we're going to do is substitution, but instead of being one variable that goes in its place, we have an entire expression, all right? So y equals all of this. So I'm going to take this, go to the other equation, and replace this y. That y is coming out. So the original equation then we're going to substitute. Take what y equals, put it in place of y. Nothing else changes. I do the substitution. Replace y with what y equals. Now I solve the equation. All right? So this is just an equation to solve. I see parentheses, so what does that tell me to do first? All right, so I have a -5 out front. That's what's going to be distributed. 6x doesn't change. Bring that down. Distribute the -5. Watch your signs when you do that. Negative times negative is positive 10x. Negative times negative is positive 45 equals negative 19. So now, combine like terms. Remember, these are on the same side of the equation. We're not doing opposites of anything here. They're already on the same side of the equation. Don't tell me you're going to subtract 10x. They're on the same side, okay? We don't need to do anything. Just combine the like terms. Now, I need to get the variable by itself. We're trying to get the variable by itself here. Now I'm going to subtract 45. Divide by 16. X comes out to be -4. Okay? Pause this. Well, any questions first? All right, pause this though. Remember what I said in the beginning. We're doing an algebraic version of the same thing that we've been doing. We're trying to find where 2 lines cross. That's what we're trying to find here. All right, if I would graph these, this is a line, this is a line, and they cross somewhere. Okay? That's going to be tough to graph. So instead of trying to graph this, we're doing an algebraic method. Now, I remind you of all that so you remember to do this. This is only half your answer. I need an x and a y. every time you do one of these problems, you need an X and a Y because, like I said, we're trying to find where two lines cross. So, once you find one variable, plug it back in to get the other variable. Again, it's substitution. It is negative 2x minus 9. I know x is negative 4, so I substitute right there. Negative times negative is positive 8. So the x is negative 4, the y is negative 1. We write our answer as a coordinate. This is where these two lines would cross if we would draw this graph. Any question? All right. Let's do it again. So, again, I have a substitution problem. Y equals this. Take what y equals and replace y in the other equation. All right? So now, it's 3x plus 14 replaces the y in the other equation. Take this, put it in here, keep everything else the same. All right? So now when I do this, I have to solve the equation. Get x by itself. What's the first step? Notice, we did a different first step here. All right? When we say solve an equation, you should know how to solve equations. If the variables are on both sides, I need to get them on the same side before I can combine like terms. On the first problem, after I did my substitution, I had distribution step. These two were already on the same side, so I just combined like terms, okay? We know that this equal sign is a very big deal when we're solving equations. We're trying to get all the variables on the same side, and we're trying to get x by itself, or whatever the variable is. Here, the variables are on opposite sides, so I need to do this minus 3x to get them on the same side, then they're combined, and then we can solve and finish solving the equation. Are we done with this problem? All right. I've got to plug it back in. I've got to get an x and a y every time. So now I take this, plug it back into the box. I really want you to box what y equals so you remember to go back and then you can find where to put it. All right? So now I take this right here. Y comes out to be 8. So your final answer is always the coordinate x comma y. It's always in that order. Don't get them reversed. All right, any questions? Let's do it again. What does y equal? Put a box around what y equals. Substitute into the other equation. So I'm taking this, putting it into the other equation. It doesn't matter which one's first or second. I need the y equals part. I need a variable by itself. All right? Now I solve the equation. I see parentheses. I'm thinking distribute. If you can't do multiplying by fractions in your head, get a calculator so you can get it right. All right? What's the next step? What's the next step? What's the next step? If you want to tell me 0.5, you get a calculator. 2 divided by 4, fine. 0.5, same thing. All right. So now I take that answer, and what am I going to do? Put it into the other equation. Drop it right there. So I substituted 1/2 for x. And there's the answer. It's always x comma y for the answer. Any questions on that one? All right, I want to do this last one. So this one, do we have a y equals? No. We have an x equals though. Okay, it doesn't have to be y equals. I just need one of the variables by itself. So this is what x equals. What variable am I going to replace in the other equation? What am I going to substitute into? Yeah, substituting in for x, because it's x equals. I'm going right there. So we keep the equation the same. Substitute x. But then I still solve the equation. However, I need to solve the equation. I see parentheses. What am I going to do? Good. Now what? Next step. Finish it up with division. Y equals 1. What do I do with that answer? Same thing. I've got to have an x and a y to finish this out. I can't just get one variable. Plug it in. So the x is -1. How do I write my final answer? Good. It's always x, y, -1, 1. The x is always written first. It doesn't matter which answer you figure out first. The x answer always comes first because it's a coordinate. All right? All right. That's it for today. We'll pick up on the rest of it next time. Good luck. Ask questions. Get to work.